Hello guys, so today we are going to build a very good end-to-end deep learning project which is handwritten text detection and recognition model. By the way, my name is Furkan Ali and I'm AI engineer. So the pipeline I'm going to explain shortly. So the code is available. First of all, I'm going to show you the code. The code is available on my GitHub repo, which I'm going to attach the link in the description. And the code is the author of this code is the main author of this code is this guy Harold Schuld. So I don't know how to pronounce his name. So he basically came up with this. Not he basically came up with this paper, which is kind of detection of the handwritten text, and then the recognition part is taken from the Keras implementation. So basically, I have combined different sort of code taken from different sources, and I have it in my own lines of code just to make it easier and complete the whole pipeline. So, and it's going to be a very interesting project. Just stick with me. So, so if you, as you can see, the detection pipeline work like, so the detection pipeline work like you give a picture, and in the picture, the detection model just detect one bounding box around one word. So zero mean zeroth line and second zero mean the word. So zeroth line, first word, zeroth line, second word, zeroth line, third word. So the first index shows the line number and the second index shows the word number. So this is how we are. So in our pipeline, every word, when we detect the bounding box around one word, they are they become they are segmented out from this image and made a smaller image out of it, out of this big image. And this is the line of code that you can ignore for now. And this is the explanation of the algorithm. If you're interested to read the paper, you can go and read everything you will find in this GitHub repo. I'm not interested in explaining in this how it is working under the hood, but but yeah, the output sample will look like you will, as I said, the word will be segmented out the big image from the big images, and then each word will be fed into the model. So, for example, first word is altered, so it's detected altered, and then here and predict, and then this comma, and then and then it up edges. So you can see this is wrongly predicted. Yeah, I'm not gonna say that it's the perfect model, but it has a lot of limitation. So, but if you fine tune it, if you do some tweaking, I think you can make it better by training just for more epochs and doing some uh, image processing kind of thing. Okay, so now let's dig it straight into the code. This is the output that you're gonna see, but this is not the overall pipeline that we have built. So over here, the detection and recognition is being done on one single word, but in our pipeline, we will be detecting and segmenting the whole line of words. So for example, we have, okay, so, oh, okay, let me run the model for you from scratch. Okay, so you're gonna run Python app.py. So this is the overall pipeline. It has the detection and recognition both implemented in one single py file. And I'm gonna show you the separate code one by one. I'm not gonna write the whole code. It's being run. Okay, so it worked like this. You give the image, test image, and it's gonna segment out the words like this. Let's cross it. And the model is being run. Okay, so yeah, as I already showed you this image on my GitHub. So let's close this. Also close this. I'll explain you the code. Okay, so you can see we have detected all the words and compiled into one single line. So you see this doorman turn us attention to the next red. Okay, so the some of the words are wrongly predicted, like next red. This was eyed word ENED. So as I said previously, it can be optimized, it can be fine-tuned. So or you can use some state of the art, but the idea is to know how the OCR works. The major idea is to know is to understand the underlying code. So then you can build up your own state of the art pipeline on top of that, if you understand first the hierarchy of the pipeline of how the code is working. Okay, so this is the end-to-end part of the code. You can from here you can just give any image and it will extract out a text for you. And then you can use a translator model or a text to voice model or anything. So you can build any application on top of this. So you can use one additional model over here, such as text to voice, or maybe first you translate this into German language or any other language that you want to translate to, and then you can use one more model which is text to voice, and then it will convert that text into the voice. So this can be there are a ton of applications that you can build on top of this OCR. Let's go into the code. So first of all, I'm gonna show you the detection pipeline. So this is the code for the detection pipeline, and I'm just doing the importing part. So I'm just gonna go over the code. I'm not gonna explain every line of code because this is self-explanatory code. If you open up my GitHub repo and you just go over this code line by line, or you execute line by line, you'll understand everything by just looking at the output. So as you can see, self-explanatory function get image file. So over here we are getting the image as an input, which can be in PNG, JPG, or BMP. So this is quite very self-explanatory, very easy code. So and over here we are just passing some arguments to give on the command line, like minimum area, image height, image width, and these are some parameters for the image processing for OpenCV, which we are doing some like edge detection, corner detection, whatever we are doing. But you don't need to do you don't need to understand what's going on inside underlying how the detection pipeline is working. So you just run this function, the detect function. If you want to understand this detect function, you can go you can go into this word detect model, word detector, and you can go in this init.py file, and over here you can read all the lines of codes. This is this is very basic image processing. So the detect function is being implemented over here. So you can see over here we are just doing computing kernel, applying 2D filters, and then applying thresholding to convert the image into into some like you can say grayscale, and then uh, we extract out the meaningful features by applying thresholding, and then we are finding the contours. Contours is basically used for plotting the bounding boxes around the detected objects, which in our case are the words. Or and so this is very basic image processing thing. So you can, as I said, you can make it advanced. You can modify the pipeline. You can implement machine learning, deep learning over here, and then we are computing kernel. So like this is and normalizing, and this is here over here we are pre-processing, and then we are doing clustering. Okay, so we have implemented dbscan, the machine learning model, to cluster out the words, and then we are sorting, and you can just go over this thing, and it's really easy. But I'll suggest just implement it as it is, because you don't need to understand the underlying code for detection pipeline, because if you are into building applications, I think you just need to know how to run the code, how to understand the overall pipeline of the code, and then you're good to go. So over here we are running the detection pipeline, image is passed, and some basic parameters that we have defined over here. Okay, let me just pause the video. So once the detection pipeline is run, and we're here, so we're here over here, we are just plotting the bounding blocks, and then we are storing the images. So as I told you before, that we are gonna segment out one word and make a small image out of it, and then we're gonna store that image into one folder which is called test images. Over here we're gonna save all the words, but with like line 0, word 0, line 0, word 1. So like this, we are gonna we're gonna extract out the words. So this is how it is working. Let me delete this folder just to show you. I'm gonna run this pipeline for you. I'm gonna delete this test images folder, and this pipeline will automatically create test images folder for you, and then it will do the detection work on top of that, and then it will create the this test images folder which I deleted just now. Okay, so so let's run python main.py. This is the detection pipeline. Okay, so this is, I already show you this output. So now this word is gonna be segmented out from this image, and it's gonna get stored into this test images folder. So you can see we had deleted this folder, and now it's created again. So let's close this thing and go and check out. So you can see we have all the words again segmented out and stored in over here. Okay. So this is the detection pipeline, and oh, sorry, not the detection pipeline is over here. Main.py. The app.py is the combination of both. So here we are just creating, we are checking if the path exists. If the folder do not exist, make a folder, and then write the images into this folder, test images folder. Uh, yeah, and like if you see, we have in our folder we have the line, which is the line word, and then we have the word, and the and then the index, their index number. So this is working like that, and we're also writing their names, the file names, into this image name sequence.txt, but you can ignore that. It's not important. We are not going to use this file. So either you can comment this out, or you can just keep it as it is. So this is the detection pipeline. Let's go towards the recognition pipeline. Okay, we have the collab over here. All right, so this is the second part of our code in which we are doing the recognition uh, of the handwritten text detection, of the handwritten words actually. So over here we are downloading the I am word data set, and then we are making the data folder, and you can see the code. It's self-explanatory. Let's go ahead. Okay, so over here we are importing the libraries, the required libraries, and then we are just doing the data splitting, which is like you are just splitting each word into a different line. We have actually the word.txt file, and you open it and you'll understand what's there. Basically, in the words.txt we have the labels, which the labels of the words that we have detected in the image. So we have the labels of those in the words.txt. And then we are just splitting the result into training, testing, and validation. And we have training samples as 86,000. We have validation as 4,823, and same as testing samples. And we are further going ahead with the data input pipeline, which is like feeding the image path into our data pipeline, because we need to get all the image from the folder and fed into the model. So for the training. So over here, we are just getting all the, because we are getting the path of the folder in which our images are stored. So you can see that we are joining the path and base image path, which is like words. Base image path is the base path is like, I can show you over here. It's like my base path is in the content data. This right now, this is not running. Okay, let me run it for you quickly. So, okay. So if you download this, I don't want to run it, but I'm just running it for you. So be grateful to me. So, because I just want to get over the code. I just want to explain the code because this is really like a baby task. I mean, a lot of video, a lot of like open source uh, material is available regarding this topic, but this is slightly advanced. This is slightly end-to-end pipeline. That is why uh, the goal is to implement the end-to-end pipeline, because on the online you will only find the word detection, word recognition, but you will not find the complete detection and recognition of the sentences. That's what I implemented in this thing. And the combination of both detection and recognition pipeline, you won't find that easily on the internet. Of course, there will be. I'm not saying there won't be, but it won't be easy to find out. All right, so let's wait for it to run. And meanwhile it's running, I'm gonna show you. So we split the desert, and then we pass the images as a path of the images, and we so over here we have like train images path, train labels, and validation images path and validation label. So just to understand this function, we have like we are passing at the end of this function, we're getting the train images path, which consists of which contains the path like this. So you can see we have the okay, where is it? Let me show you my yeah, like this. So these are train images path. So I have run 10 images. I have taken 10 images first. So this is first image, second image. We're gonna make the list out of it. So and the labels will look like where is the label? Okay, let me show you the labels as well. Okay, first of all, I have to run all of this thing. I have run this thing, and let's run this one. So this is just to show you the what is contained, what is in the words.txt. As I explained, this is the words.txt contains a label of the images. And okay, so let's run this one as well. And we have words list. We have like sure, he, during, in, during, like this kind of thing. And then we were doing splitting part. Okay, so I was showing you what is inside the data image. So inside the data, we have words, and inside words, we have like subfolders, and then in subfolder, we have the images. So these are the images. So you can see these are the images of the words. And for further explanation, you can go on the IAM word dataset uh, website, and you can read what is this dataset about. Okay, let's further move on. And this is the labels words.txt. So we pass the base image, base path like this content slash data. This is the base path. This contains the images, and this contains the label words.txt. I'm gonna shrink it up. Okay, so data input pipeline, we run this thing, I guess, or not. Okay, let's run it again. Okay, I'm gonna show you this. Okay, where were we? We were running. Okay, we were supposed to run this train labels, right? So as I already showed you how it looks like. So I'm gonna explain this code. This part. This is very important part actually. There are some people who have asked this question regarding uh, the sorting of the images, because when we recognize the images, the words must be sorted, because first word cannot come in the last, and last word cannot come first. So they must be sorted so that it can complete the sentence. So for that, this part is the most important part. Although these are very limited, very few lines of code, but they play a very big role. They are like a small b, which is like if you wanna. So there's a very famous quote. So if you wanna see, uh, uh, okay, I forgot the code. Let's just focus on the code. Okay, so you can see the labels like no, more, the, it, blah blah blah. Okay, so these are the labels with their coordinates actually. Like this is these contain the coordinates, like where are this image, where is these bounding boxes detected. So like XY coordinates. All right, so this is for training pipeline for training images and training labels, and this is for the inference part. Like when you will download the image from the internet, or you will write your own handwritten words, and you will take the image, and then you have to pass that image as for the inference part. So this pipeline is for that. So for example, you uploaded the testing image in your drive, and then you pass the image folder over here, like test images as I passed. So this test image contains the image that I'm gonna run. Uh, I'm gonna pass through through my model for the recognition of the words or the text. So I'm over here. I'm just making the list of my training images. Oh, sorry, testing images. T is for testing, and here you can see. All right, so okay, you're not going to pass one single image into this model, because this model is not for trained for detecting the lines or recognizing the lines. This model is trained to recognize the words. Keep it, this is very important part, you need to keep it in your mind. So what you're going to do, if you have a picture which contains lines of words, handwritten lines of words, what you will do, you will first pass through the detector. The detector will segment out the words and break them into the smaller images, sub-images, and then you will pass those sub-images into this pipeline. So test images basically is the folder that contains the sub-images, like the images. You remember the folder that we created during the detection? This folder? This is the actually folder that we are passing through that inference part, test images. It contains many sub-images. So this is the folder I'm showing you over here. Yeah, this one. So yeah, this one. This is the folder actually. Yeah, the name is slightly different because in my drive I have given some different name. So this is the folder actually, and then you are joining the path, and then you're appending and then printing. So you can see line 7, word 5, line 7, word 7. So you can see this is not sorted at the moment. So the words are sparse, they are spread over each here and there. So what our goal is to sort these words, so when we recognize these words, we can compile them back into one sentence properly. So we need to sort these images as well, like line 5, word 7, and over here the line 5 was over here the line 7 came first and line 5 is coming afterwards. So so how are you gonna do this work? Like how are we going to sort this thing? For that, we are running this line of code. So what it does, you just run it as it is. You don't need to so you can see we are like passing the text, and it is like so you see we have line 0, word 0, line 0, word 1, beautiful. Line 0, word 2, line line 0, word 3. So you see it has sorted all the images for you. So if you run this, yeah, so if you run this thing, oh, we already run this thing. Okay, we don't need to run it again. Okay, train images path, train labels. I already show you the output. Okay. So we are preparing the ground truth labels over here, which so we are just preparing the labels over here that we're gonna feed into our model. So just run it as it is. And the important part is we are extracting out the characters from the words. So we are doing the character based recognition. Just keep it in your mind. So we have to extract out the unique characters from our list of images that contains the words. So we over here we are cleaning the labels, and then we are okay. So this is also a very important part. When you pass the list of characters, first of all, I should show you the list of characters. So when you pass the list of characters into this, okay, so you see the list of characters. These are the list of unique characters because set is for a unique thing. Okay, so these are the words and the characters that we. These are the words. These are the characters that we detected in our words, the unique characters, and it contains till Z, and we are passing the characters into the list. Now, when you pass some set into the list, the alignment of this thing goes it does not stay in the order. So, for example, this zero is coming before one, but after you pass it into the list, it might come at the end. So I can show you like how what I mean actually. So if you run this thing and you just run ff, let's see. Okay, so surprise. You see, like it is like IBTR. So it has dispersed everywhere. Now it is out of order. So whenever you renew or rerun this notebook, every time it will it will have a new sorting. It will not be in order. And it's going to affect huge it's going to put a huge effect on your recognition pipeline. What you need to do is to make sure that every time you renew the notebook or every time you run this or you deploy this thing into production, your this sorting this must be in order. Like it must be same as right now. So it must not differ. For that thing, what I did was this is my so what I did was I came up with the approach which is like I stored the list into this pickle file. I just I just got the character list and I passed and I saved this into the ff variable, and I stored that into the pickle file. And once it is and that the pickle file is stored in my drive. So every time when I run this notebook, I have to load this characters list so that it stays in this in the exact format. It does not change its format. It does not go out of order again because then the recognition pipeline will not work. So this is the solution to tackle this problem. Like this is currently ongoing problem, and this is my approach of dealing with it. So I'm gonna load my file, which is like characters. I have stored characters in my collab in my drive actually, and I'm gonna load it again. And then over here we are just passing. We are doing the string lookup, which is like character to number. When you pass a character, it will convert to number, and when you pass a number, it will convert it back to characters. And then we are doing resizing. I've put all these explanations so that when you run it again, you don't forget what we are doing in this function. So like we are doing distortion free resize, just run it as it is. And then we are doing the, okay, so if you just go with the plain resizing, then the image would look like this. We're putting the utilities together. All right, so what we are doing over here is to, okay, we are doing pre-processing, which is like in the distortion free resize function, which is written over here, what we are doing is we are adding the padding. Now, what is padding? Now, every file has a different size. Every image has a different size. So to make sure that every image has the same size, because our model cannot accept different size of images. Some words are small, some words are big. So in order to resolve that problem, what we do, we add padding. So if some of the images are very small, so what we will do, we will add extra padding to those images. And some of the images, if they are like very big, uh, we don't need to add padding in them. Okay. So this is what we are doing in this pre-processing images file. We are passing the images into distortion-free resize, and then we are just typecasting the image, and we are normalizing it actually. And this pre-processing for vectorizing the labels. And this is also for the labels, and then we are doing the preparing of the data set. And we are making the okay, so we are making the uh, we are passing the images path and the labels, and it will prepare the data set pipeline for us. So let's run it as it is. Okay, so here we are preparing the data set pipeline, prepare data set, and we pass the image path and the labels. And for the training, validation, testing data set, and then okay, this one is for inferencing part. So as I told you, when you pass I explained above, when you have your own image, you want to pass it to the model. So this one is slightly different code than the above one, but almost same. I deleted some of the line for like labeling part. For example, over here, if you see, I have commented out the label thing and only image. Here you're getting image and label as well. Here you're just getting image because the model itself is going to predict the label for you. So this is for inference part. Okay, visualize new test images, or let's say, okay, let's plot this thing. This is for visualization. Okay, let's why is it taking so long? Okay, meanwhile it's running. Let's go over the model. Okay, so this is the model. The major part of the innovation is in this CTC loss, which is like written over here, CTC layer. We are computing the loss over here, and we are building the model in this function. We are passing the input image and labels, and we have convolution 2D layers, and then we have convolution 2D layer again with max polling, and then we are passing that through the bidirectional pipeline just to retain the context of the word or the characters. And then this is the overall pipeline of the model, which is like self-explanatory. I don't need to explain much. And this is the model output which we will get. Okay, so this is like okay, it will look like this thing. The doorman on his attention, blah blah blah. Okay, so this is the visualization of the label. So this is the padding actually. So if you see, this image is small, but we added extra padding. This was big, but we added less padding, and this was a little bit more big. We added less padding. So the padding is very important for different size of images. This is what we are doing in the pre-processing function. Let's run this model, and this is the evaluation matrix for evaluating our model, and calculating it added distance. Okay, this is all for for evaluation of the model. So just run it as it is, calculating mean added distance for each epoch, etc., etc. And here we are running the training for 50 epochs, and so as you see, I'm not gonna run it, or I'm gonna run it just to show you that it's working, because you will say it's not working, you gave us wrong code, etc., etc. But I'm just gonna show you that it's working code. I'm not sure if I'm using GPU. All right, I'm using CPU, so it's gonna take huge amount of time. So I would recommend using GPU. So I'm gonna stop the training so you can see, you can verify that the training is working actually. So I'm just gonna stop the training, and this is the inference pipeline. In the inference pipeline, we have to decode the prediction, which we get it. And then for example, we are taking one batch of images, which is like 16 images from the test data set, and we are doing all the pre-processing, and then we are passing through the model prediction pipeline. And then we are doing the decoding part. Decoding it part is like we found the word, or we found the characters, and then we have to convert them back into we got the number, and then we have to convert them back into the words, into their respective characters. So this is what we are doing in the decode batch prediction. And this is like altered here. So this is the inference part. So this is overall what we say is the recognition pipeline. Okay, for the inference, for your own testing images, make sure that you pass the CTC layer as the custom object, because CTC layer is not the part of your model. You created it separately. As you can see over here, the model is over here, but CTC layer is defined separately from the model. This function is not inside this CTC layer. CTC layer just contains these two functions, but this build model is outside this CTC layer. So that's why I'm passing the CDC layer into the custom objects, because when you load the model, I saved the model over here. Yeah, I saved the model like model.save. You just need to run model.save. Don't run these above lines. You need to run model.save, prediction model.save, and then your path. Okay, when you will load it at the inference time, what you will do, you will, okay, so you will pass the CDC layer, you'll pass the save model path, and then the custom object, which is the CDC layer. And once it is loaded, you will do the you will make we have a prediction test text, and we have the same function, which I showed you above, the decoding part, and we pass the your own images of the words through this pipeline, and then you get the prediction. Okay, so once you get the prediction, you will run this okay, you will convert the prediction into the flat list, just like, and then you will convert them back into the sentences, so like doorman turn attention to the next. So this is the complete pipeline of detecting and recognizing the words, the handwritten words out of uh, in the image, and you will get the whole sentence out of the. So we just converted a word recognizing model into a sentence recognizing model. So this is how it works actually. And now I'm going to show you the overall pipeline, which contains both. So I'm just going to go over it very quickly, because this is the same code that I showed you in those two files. So I don't need to explain them again. Explain already. So let's just go over it very briefly. So this is like we are doing the direction part over here, and okay, so this is all the direction part, and we are just telling it where to store the images, which is test images folder over here, and then we have the recognizing part starting over here. So let's call it recognizing part below. Okay, so base path. So we are telling the okay, we are going to pass the testing images base folder, because we have to pass the words which are stored in this test images folder. We have to pass the words into our recognition model, and this is overall the same code that I showed you right now. And yeah, at the end of the day, you're going to print the sentence, and the sentence will look like these that I showed you. Yeah, so this is how it's gonna work. So we have this file contains the detection and recognition, and and the model that I'm using. Uh, I have given the save model on my GitHub, so you can download from my like this characters list, which I showed you for the unique characters that we are storing. Okay, so this is running. The code is running behind the. Even the notebook I have given, like handwritten text detection, it is actually recognition notebook, not a detection. So you can rename it. And also the same model, which is for train for 50 epochs. So you don't need to train it on your own. You just need to plug and play. And okay, and what else? What else? I think that's it. You have everything. You don't need to download anything from outside this notebook or this GitHub, because I have given everything. I think I'm so generous. The doorman turn, so you can see we have the sentence at the end, and from here you can go anywhere. You can do anything you want. So I'm gonna push it to the GitHub, and I have already pushed it to the GitHub, and you can download and then play it, optimize it, and fine tune it, and make the better model, make the world better, build some cool application, and then send a thanks message back to me. Thank you so much, guys. This was the overall OCR complete end-to-end pipeline. Till next time, I'm gonna come up with new project, some state-of-the-art new end-to-end pipeline, and hopefully we're gonna meet soon. Okay, thank you. Bye bye.